Let's look at PV diagrams. I'll just introduce them. Suppose that I have a container with the gas, it's concealed, and I add heat. Well, that heat would cause that piston to rise, and that's what makes heat engines work. It's that you want that piston to do mechanical work, and there's various processes that describe what happens when the piston comes back down, when it's going up, and there's various processes that are put on a PV diagram. And first of all, the word iso means the same or equal. You need to know that, it'll help. And I'm going to describe 4 processes. First of all, isothermal means same temperature. In other words, if the process happens at a constant temperature, this is what the graph will look like. Now, PV is nKt. Well, if it's constant temperature, the number of molecules is not going to change in there. Neither is K the constant temperature. Therefore, PV is a constant. And if PV equals a constant, here's what the graph looks like. It is exactly like that. And so that's what you need to know. Again, let's say that again. If PV is a constant, it's an isothermal, then you get a graph shaped like that. Now, one more thing about this graph. If the temperature doesn't change, neither does the internal energy. Therefore, if I have, the internal energy is 3/2 nRT, you've memorized that, then, if the temperature is constant, the change in the internal energy will be 0. Now, just watch through that a couple of times, you'll understand that process. Another one, you can read about this in the book, it's called adiabatic, and it means no heat is added or removed. Again, it's worth memorizing that. And it looks like the isothermal, except it's always lower. It would be at a lesser temperature. Now, if no heat is added or removed, Q is 0. And from the first law, the change in the internal energy is Q plus W. Q is 0. The change in the internal energy is W. Isobaric means same. Well, think of a barometer. Baric, barometer, and this means the same pressure. A barometer measures pressure. And if you have the same pressure, unchanging pressure, that's what the graph looks like. Several things about this. If PV is equal to nKt, well, if the pressure is constant and the volume is changing, that means so does the temperature. And remember, all temperatures are in Kelvin here. So if P is constant, the temperature will change. One more thing. In this graph, to find the work done, it's the area under the curve. The area under the curve. And remember, if it's the work done on the system, it's positive. If it's done by the system, it will be negative by our way of working this out. Isochoric means same constant volume, and that's what the graph looks like. It's a vertical line. No work done. There's no area. And so PV is nKt, and if the volume is constant, well, that means that the pressure will change, and of course the temperature will change also. I suggest you read through the pages on PV diagrams in the book, and just know the basics.